ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. ಈ ವಿಡಿಯೋದಲ್ಲಿ ಸೊಲ್ಯೂಷನ್ ಆಫ್ ಲೆಗ್ರಾಂಜಸ್ ಲೀನಿಯರ್ PDE ಅನ್ನೋದ್ರ ಬಗ್ಗೆ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಿದ್ದೀವಿ. ಲೆಗ್ರಾಂಜಸ್ ಲೀನಿಯರ್ ಪಾರ್ಷಿಯಲ್ ಡಿಫರೆನ್ಷಿಯಲ್ ಈಕ್ವೇಷನ್ಸ್ ಅನ್ನು ಹೇಗೆ ಸಾಲ್ವ್ ಮಾಡೋದು ಅನ್ನೋದ್ರ ಬಗ್ಗೆ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಿದ್ದೀವಿ. ಸೊ ಪಾರ್ಷಿಯಲ್ ಡಿಫರೆನ್ಷಿಯಲ್ ಈಕ್ವೇಷನ್ ವಿಚ್ ಈಸ್ ಆಫ್ ದ ಫಾರ್ಮ್ capital P small p plus capital Q small q equal to R is called Lagrange's linear PDE. Here the additional condition is the terms in this equation, this PDE must be of first order and first degree. This equation must be a partial differential equation of first order and first degree. Then we call such equation as Lagrange's linear PDE. The solution of this equation will be of the form phi of u comma v equal to 0. We have to explicitly find out what is u and v. U will be usually a function of x and y and z, and also v will be a function of x, y and z. We need to find u and v, then we can finally write the solution in the form phi of u comma v equal to 0. The working procedure for this type of problems is as discussed here. Working procedure: you will be given with a linear PDE, Lagrange's linear PDE. So the given equation will be generally of the form PP plus QQ equal to R. PP plus QQ equal to R. You have to identify this capital P, capital Q and R in the given equation. First step is write the given linear PDE and identify capital P, capital Q and capital R. Second step, you have to write this in the form dx by P equal to dy by Q equal to dz by R. You have to write that in the form ಈ ಥರ ಬರ್ಕೋಬೇಕು. dx by P equal to dy by Q equal to dz by R. Now next, so try to solve this by separation of variables. That means you have to consider this pair, then check whether this can be written in the form. I'll write here. Check if it can be written in the form. Separation of variables use ಮಾಡೋಕ್ಕಾಗುತ್ತಾ ಅಂತ ನೋಡಬೇಕು. Written in the form f of x into dx equal to g of y into dy. So that means you have to try to separate the variables in this pair and then consider this pair. So pairwise you have to consider, then try to apply separation of variables if it possible. If it is not possible, then you have to choose multipliers. If not, by proportion rule, by ratio and proportion rule, I'll write that rule here. We have, see, from a ratio and proportional rule we have this one, a1 by b1 equal to a2 by b2. Three ratios are given which are equal. a1 by b1 equal to a2 by b2 equal to a3 by b3. This is equivalent to k1 a1 plus k2 a2 plus k3 a3 divided by k1 b1 plus k2 b2 plus k3 b3. So this is the rule of ratio and proportion. Now I have to use this rule here. Choose multipliers. K1, K2, K3 are called multipliers. If separation of variables is not possible, choose multipliers k1, k2, k3 such that see, choosing that multipliers, the expression dx by p equal to dy by q equal to dz by r can be written in the form k1 into dx plus k2 into dy plus k3 into dz divided by k1p plus k2q plus k3r. This I have written from this rule, ratio and proportion rule. And there should be additionally one more condition to choose multipliers, that is this denominator must be 0. k1p plus k2q plus k3r should be 0. So I had to choose multipliers in that way, so that k1, k2, k3 must be chosen such that k1 into p plus k2 into q plus k3 into r should be 0. Then the solution will be integrating the numerator term, what is the numerator? k1 into dx plus k2 into dy plus k3 into dz. So integrating this factor or this term, we get the solution u of x comma y comma z. See, this part we get. You had to choose one more pair or one more triplet, k1 dash, k2 dash, k3 dash, such that k1 dash into p plus k2 dash into q plus k3 dash into r should be 0. Again, integrating the numerator term, you get v of x comma y comma z. So the final solution will be phi of u comma v equal to 0. So this is the working procedure. So given the linear PDE, first you have to check, you have to identify capital P, capital Q and capital R, comparing the given equation with this, compare with this to get capital P, capital Q and capital R. Then write that in the form dx by p equal to dy by q equal to dz by r. Now check whether separation of variables can be applied to this. Then if it is possible, then separate the variables. First e pair consider madkoli, cross multiply and separate the variables, then integrate, you get the solution. Then consider this pair, or you can consider dx by p equal to dz by r, then you get another part of solution. First u sigutte matte innೊಂದು pair ತಗೊಂಡ್ರೆ v sigutte. If separation of variables is not possible, then go for this multipliers rule. So you have to choose multipliers k1, k2, k3 and k1 dash, k2 dash and k3 dash such that k1 into p plus k2 into q plus k3 into r equal to 0 and k1 dash into p plus k2 dash into q plus k3 dash into r should be 0. Then integrating the numerator term, you get the solution. So that's about working procedure. Now let us try to solve some problems. Problem A, solve xp plus yq equal to z. Solution. So given xp plus yq equal to z, compare with pp plus qq equal to r. So what we get if you compare with that equation, capital P will be X, capital Q will be Y, capital R will be Z. Now that is the first step. Next step, we have to write this in the form. Now we have dx by p, that is dx by p. Okay, I'll write one more step. Dx by p dy by q equal to dz by r implies dx by x dy by y equal to dz by z. Now look into this. Here you have function in one variable x, here you have function in one variable, that is y. So now you can separate the variables easily. Actually unless separation apply agide, you have all terms containing x in one side and terms containing y on the other side, nothing to separate. You can easily solve this one. So considering the first pair, dx by x equal to dy by y. Variables are separated there only, no problem. Integrating, so I'll get integral of dx by x equal to integral of dy by y plus the constant c1. So ಎರಡು ಕಡೆನೂ log ಬರೋದ್ರಿಂದ I'll write that constant as log c1. ಎರಡು ಕಡೆ ಲಾಗ್ ಬಂದರೆ ಅವಳ ಕಾನ್ಸ್ಟೆಂಟನ್ನು ಲಾಗಲ್ಲೇ ತಗೊಳ್ಳಿ. ಸೊ ಫ್ರಮ್ ದಿಸ್ ವಿಲ್ ಗೆಟ್ ಲಾಗ್ ಎಕ್ಸ್ ಪ್ಲಸ್ ಲಾಗ್ ವೈ, ಸಾರಿ ಈಕ್ವಲ್ ಅಲ್ವಾ, ಈಕ್ವಲ್ ಟು ಲಾಗ್ ವೈ ಪ್ಲಸ್ ಲಾಗ್ ಸಿ1. ದ್ಯಾಟ್ ಇಂಪ್ಲೈಸ್ ಲಾಗ್ ಎಕ್ಸ್ ಈಕ್ವಲ್ ಟು ಲಾಗ್ ಆಫ್ ವೈ ಸಿ1. log a plus log b equal to log ab. So from this I'll get log, okay, comparing both sides, log terms will get x equal to yc1 or constant ಒಂದು ಕಡೆ ಬರ್ಕೊಳ್ಳಿ, ಉಳಿದ ಟರ್ಮ್ಸ್ ಇನ್ನೊಂದು ಕಡೆ ಬರ್ಕೊಳ್ಳಿ. x by y equal to c1. Later you have to take only this functional part, constant ಕೊಡೋಕು functional part ಮಾತ್ರ ತಗೋಬೇಕು, that will be u. Okay, I'll write here. This will be u of x comma y comma z. Next, what do you have? First I have taken this one, dx by x equal to dy by y. Next let us take this, dy by y equal to dz by z. dy by y equal to dz by z. Integrating, I'll get integral dy by y equal to integral dz by z plus the constant again I have to take in terms of log. Now log y equal to log z plus log c2. So I'll get log y equal to log of z into c2. Now comparing terms on both sides, I'll get y equal to z into c2 or y by z equal to c2. So from this v of x comma y comma z equal to functional part you have to take y by z. The required solution is phi of u ಏನು ಬರುತ್ತೆ x by y comma v y by z equal to 0. This is the required solution. Let us take one more problem B. Solve solve P cot x plus Q cot y equal to cot z. Solution. So you are given P cot x plus Q cot y equal to cot z. Now I have to compare with PP plus QQ equal to R. So we get capital P equal to cot x, capital Q equal to cot y, capital R equal to cot z. Now writing this in the form, next dx by p ಅಂತಂದ್ರೆ cot x ಅಲ್ವಾ, cot x, then dy by q equal to dz by r, that is cot z. Now here you can use separation of variables, because this side you have dx by cot x, that is a function in one variable, again dy by cot y, that is a function in another variable. So you can use separation of variables. So by separating the variables, we have, first consider this pair, dx by cot x equal to dy by cot y. That implies integrating, so I'll get integral of dx by cot x equal to integral of dy by cot y plus, see anyway we get log term here, so I'll take the constant in terms of log c1. Now integral of dx by cot x, that we can write as, so we can make this expression much simpler. So like a start ಮಾಡ್ಕೊಂಡು ಅನ್ಸುತ್ತೆ. Okay, I'll do one thing. I remove this. Before I'll write this expression as tan x dx equal to tan y dy. Yes, this is best. Now integrating, so I'll get integral tan x dx equal to integral tan y dy plus log c1. Yes, now it is okay. So integral of tan x, that will be log of secant x equal to log of secant y plus log c1. So from this, log secant x equal to log of c1 into secant y. So I got from this secant x equal to constant c1 into secant y, or constant ಒಂದು ಕಡೆಗೆ ಉಳಿದದ್ದು ಇನ್ನೊಂದು ಕಡೆ ಬರ್ಕೋಬೇಕು. secant x divided by secant y equal to c1. So from this we got u. Next, similarly we have dy by cot y. Similarly we have dy by cot y equal to dz by cot z. So from this one I can write tan y dy equal to tan z dz. Integrating, what we get if we integrate this, integral tan y dy equal to integral tan z dz plus log c2. So this is log of secant y equal to log of secant z plus log c2. So with the usual simplifications, finally I'll get c2 equal to secant y divided by secant z. Alva. So the solution is, hence the solution is phi of secant x divided by secant y, comma secant y divided by secant z equal to 0. So that is the required solution. Let us consider one more. Solve C, problem C is solve y square zp equal to x square times zq plus y. Solution. So given y square zp equal to x square zq plus x square y. So I can write this in the form y square zp minus x square zq equal to x square y. So here p equal to y square z, q equal to minus x square z, r equal to x square y. Now dx by p equal to dy by q equal to dz by r implies dx divided by p ಅಂತಂದ್ರೆ y square z equal to dy divided by minus x square z equal to dz divided by x square y. Now you can separate the variables here. You can use separation of variables. Solution. Okay, next step. So first consider, let us try to consider this pair. See, if you consider this pair, z get cancelled, x square dx you will get one side, y square dy you get another side. So first dx by y square z equal to dy by x minus x square z implies z get cancelled. We'll get minus x square dx equal to y square dy, or this is equivalent to x square dx plus y square dy equal to 0. X square dx plus y square dy equal to 0. Integrating this you'll get integral x square dx plus integral y square dy equal to 0. That implies if you integrate x square you get x cube by 3 plus y cube by 3 equal to constant c1. See, I have to write here constant, integral of constant, that is c1, integral of 0, sorry. Okay, from this I'll get x cube plus y cube equal to 3c1. So I got one solution, one pair of solution from this. U was signaling, so u is x cube plus y cube. Next, so let us consider second and third one. This dy by minus x square z equal to dz by x square y. So considering this, I'll get, okay, x square get cancel, x square get cancel. So I'll get y dy equal to minus z dz. So from that, y dy plus z dz equal to 0. Now integrating this, you'll get y square by 2 y square by 2 plus integral of z square by 2 equal to c2 it is, or y square plus z square equal to 2c2. Hence the required solution is phi of x cube plus y cube comma x square plus y square, y square plus z square, it is y square plus z square equal to 0. This is the required solution. So with this we have discussed 3 problems on Lagrange's linear PDE. In the next video we shall discuss a few more problems on this. Thank you.